My name is Joel Kurtzman. I'm a senior fellow at the Milken Institute, and I would like to welcome all of you to the Road to Profit in Alternative Fuels. Let me introduce the panelists. On my right is James Cameron, Chairman, Climate Change Capital. Yossi Hollander, Chairman and Co-founder, Fuel Freedom Foundation. Chris Hostetter, Group Vice President, Strategic Planning at Toyota Motor Sales USA, and Andrew Littlefair, President and CEO, Clean Energy Fuels Corporation. And there are more extensive bios in your packs that go into the details of each panelist's background, which is, I really recommend reading because it's very extensive, and what these panelists have achieved. This is just the latest set of accomplishments on very distinguished careers. So let me just set the scene for a second about what we want to investigate in this panel. And the question is, of course, do alternatives have a real future in the transportation sector? And if so, are there opportunities as well for investment in that sector? What are people doing? What should they be doing? What's the overview of this sector, and what can we forecast for the future? And I think we need to take into account some big developments that are taking place. And before we get into the panel, I'd like slide 3, please, if you could put that up. This is my favorite slide. I'm not an engineer, although I do like engines. And these two engines, I actually wrote an op-ed for the Wall Street Journal about these two engines for the simple reason that these are natural gas engines, and they are specifically designed for both long-haul and medium-haul trucks, short-haul trucks, deliveries. Now, this is simply one alternative in terms of the technological opportunities in front of us, but it is a departure. It does signal in many ways at least some cracks in the overall gasoline, petrochemical, diesel dominance of this one sector, and a movement away from the traditional fuels to what Yossi is looking for, which is a overall market for different types of fuels, which would return in many ways choice to the consumer. Now, I raise this, but what I'd like to begin with is what Toyota is doing, which is a very significant commitment to a different direction, to a new set of technologies, and to, frankly, the requirement for new supporting infrastructure. That's great. Chris, could you talk a little bit about what Toyota's up to?
Okay, I'd love to. The starting point for us really begins in the early 90s when we laid down two major strategies which we felt represented the future of mobility, the future of environmental leadership, which is what is our top priority. And the midterm solution was really the electrification of the car. And that led to the Prius and the hybrid, there was a lot of skepticism when we launched the hybrid, if you recall, about whether the additional investments and all those components really would pay back. The result of that has been 6 million sales of hybrids worldwide and 25 hybrids in our lineup globally. So the hybrid has been a success story. But at the same time that we laid down that hybrid strategy, we also laid down a second strategy, and that was to develop a fuel cell electric vehicle. And the fuel cell electric vehicle project had started in '92 in the same time, and we've gone through 11 or 12 generations of fuel cells. We've taken out a lot of cost, which is the platinum. We've improved the durability. We've made them operate in Yellowknife, Canada at minus 30 degrees below zero. They last twice as long as batteries, and they have the convenience that people need. I'd like to pull up slide 12 and show you what we'll be introducing in California next year. That's 11. What we'll be introducing in California next year, and then after that on the East Coast, is a mid-size four-door sedan which will be our fuel cell electric vehicle. It has over 300 miles of range. It refuels in 3 minutes. It manufactures electricity on board. It uses hydrogen as a way to store that energy, which is much lighter than batteries. We believe for larger vehicles, hydrogen will be the fuel of the next century. We are very committed to it, and we also believe still in electric vehicles, but we feel that electric vehicles are more appropriate for the smaller sizes. And so you could see in our portfolio that reflection of that strategy. From the Consumer Electronics Show, we had a plug-in motorcycle called iRoad. We also have a plug-in hybrid on our Prius. But this invention of hydrogen is the key to our future. And in the state of California, if you're familiar with the zero-emission vehicle mandate, to achieve 80% greenhouse gas reduction by 2050, over half of the vehicles, probably in 2030 and beyond, will be fuel cell or electric. And we believe that fuel cell, due to its convenience to the customer, no range anxiety, no temperature issue, will really become the standard of the future.
And tell us a little bit about what kind of engineering commitment Toyota made. On the one hand, you said this is the 11th version?
Yes.
Iteration?
The 11th iteration of the fuel cell stack itself. We've been able to reduce the size and increase the power. Okay. It's leading power, but it's about the size of a carry-on suitcase. It uses a lot of the components from the hybrid electric vehicle in terms of motors. It does have a power system that ups the voltage, so it corresponds with the rest of our hybrid. It has a small battery for taking back energy of braking and acting as a buffer. And it has 2 hydrogen tanks that are very, very high tech. We showed them to the Secretary of Energy, Chu, a few years ago in terms of how it was an outgrowth of our textile process and what we learned in carbon fiber. And the fuel cell itself, there's a Moore's law in our area about the cost reduction that's capable in a fuel cell device. And we believe the fuel cell device has twice the speed of cost reduction possibility that the batteries do. Over the next 2 generations.
Now this is going to take an investment in infrastructure in order to support this with hydrogen and so forth. So let me turn to Andrew before we go back to Toyota. Andrew, you've set up a company over the last few years that is fueling vehicles, primarily commercial vehicles, sexy things like garbage trucks and things like that use natural gas. Now, you are the infrastructure, essentially, for this new type of vehicle ecology. How did is that a tough thing to do? Was the market ready? Did it take a huge amount of investment to get something like this off the ground?
Sure. So we figured out early on, we're in a different business than Chris is here. We really needed to focus on those vehicles that use a lot of fuel. So we really began to target. You can't build a natural gas infrastructure and expect people to show up, build it, and they will come. It doesn't really work that way, at least. It may someday, but in the early going, it didn't. So we had to base load those stations with high fuel use customers. So we really focused on vehicles around the airports and refuse trucks and buses, and they got good economic.
Refuse. I shouldn't have said garbage.
Well, I know. Garbage trucks are fine. They don't like trash trucks. I know
trash.
That,
okay.
But actually, they prefer solid waste trucks.
Solid waste.
But so that's how we got started. Today we have about 500 stations. The next market is and again, this is really fleet, so it's different than the Toyota's early, I guess, introduction and more of the mass market, is the heavy-duty truck. So we've now built a nationwide network of truck stops with CNG and LNG. But it's expensive. I have a hydrogen fueling station at LAX, and so I don't envy what you're up against, because you really are trying to change the paradigm, and it's hard, it's tough going in the beginning, and the technology's not great, but after time, the investments come, and you can get good payback. I'd like to ask them to pull up number 9. Joel, I just wanted to segue here, because to me, I appreciate, let's see, so 9, it's got a bunch of logos on it. Yeah. To me, this is what's exciting. So I appreciated the 2 red engines, because we love those, because they burn the fuel that I sell. But this is what's new, and I don't know if in the audience you could see it. So every original equipment manufacturer in the heavy-duty truck space, either that makes engines or makes vehicles, is now either has a natural gas engine or offering on the road or is announced it. And when you look at the light duty, which is below the line there, those are all the manufacturers around the world that that have natural gas vehicle product on the light duty side. So when we started here in the Port of LA with the first heavy duty trucks, we had to buy the first 100 trucks, Joel, to tell you how to get these things going, from Kenworth to get them even to put a Cummins Westport engine in their truck. Today, around the world, every manufacturer's got natural gas product. And to me, that's exciting as we move down this line.
So what you're saying, if I understand you correctly then, is that your introduction of a new fuel required a very strategic set of choices around location to be near your market. In your case, you could identify the passenger sector is very different, but in your case, you know where the airport is and so forth, so you could do that.
And you knew the vehicles, and then you could work with your original equipment manufacturers, or even in the early days, upfitters, to make sure there is product for those particular vehicles.
So let me turn to Yossi and get your perspective, Yossi, from someone who's essentially trying to open up the market to as many fuels as possible and truly create a market, since with only one narrow slice of fuels, we don't really have a market. We have a single commodity. Do you see this as viable in your statistical analysis, in your capturing of data and so forth?
I think one of the things we have to ask is that viable for what and when? People always say, oh, there's a new technology, it's going to be great. And, I love new technology. I'm a high-tech guy. So I want new technology. I don't know how to decide today from our vantage point whether the regular electric car or the hydrogen cell electric car or the methanol fuel cell electric car will be the winner, or maybe all three of them. But definitely we're not talking about anything that will have significant impact on the price and economy in the next 20 years. Even I think in Toyota's plan, it's only, as you said, 2030 and onwards is where massive scale starts coming in, if you succeed. On the other hand, if you look at the natural gas market, it's a very specific distinction. It's a very different market. It's economical for high mileage application. If you try to apply the natural gas CNG logic to regular cars, if you look at the numbers, they don't work out. Okay, I can go into the why. So we actually have to always look. This is a $3-4 trillion market around the world, and there's no reason to have one solution. Okay, I mean, we don't have anything like that in anything else. We have competitors. You go to the supermarket, you have quite a few cereals on the shelf. Okay, and the government doesn't tell you can only take 91 or 87. Okay, you pretty much decide what you want. And that's the idea that we want, and we also want to do it in a very short time scale. So we want a choice at the pump for the vehicles you currently drive. We basically say if we want to reduce the price of gasoline or fuel to the population today, to the American driver, you have to do it with the current fleet. So we figured out that most cars on the road could probably be converted to run on other fuels with very small investment. And other fuels are ethanol and methanol. And some of you immediately say, oh, ethanol is bad, what is methanol, etc. There's many fuels that are out there. Those are liquid fuels, okay, that exist out there. And they run cars. And today they are cheaper than gasoline. We think they run around at $2 a gallon, basically, before taxes. So it's about $1 cheaper, or 80 cents compared to today's price. We don't want to decide which one will be a winner. We think that maybe in Iowa, probably most likely corn ethanol will be cheaper for quite a long time than any other solution. It could be that methanol from garbage in LA will be very, very cheap, okay? Because currently it costs us negatively to send it out, okay? It could be that in the Bakken, which they flare $1 billion of natural gas every year right now, so the value of it is zero, okay? You can make methanol or ethanol from natural gas at a very low price. We don't need to have one solution for all of America. We don't have that in anywhere else. If we have flexibility in the cars, and we can drive from different places and have them in different stations, I believe that is the solution.
But don't you think, I mean, as Chris was saying, I mean, his new vehicle is the result of 11 iterations of engineering. That's very costly. If Toyota or any other manufacturer then has to make 5 or 6 or 7 types of propulsion systems for their vehicles, isn't that going to make the sector just prohibitively expensive?
Well, they're already doing it. So what happened, I believe, with most, I don't want to comment on Toyota specifically.
No, but I'm saying in general.
But in general, the car industry was facing a serious problem about 10, 15 years ago, that every regulation in car market and fuel in the world was changing. So we have 8791 in Europe. They have octane. In Europe, they have 95, 96. We forbid MTBE. They allow it. We have different types of aromatics. Brazil wants 100% ethanol. So you can't build a different engine for every market. So that decision drove them to do a global platform for their engines. And you show a picture of an engine. I don't think that's the engine anymore. That's kind of a metal that runs. The engine is the little computer that controls it. Okay? That's the engine. Okay? And that computer. What?
Don't tell that to the guys at Cummins.
And that computer is what separates the different engine for different markets today. And that same computer, by playing with that computer, we can run different fuels on the same engine.
Okay. So let's, before we get into a general discussion of this, I'd like to get James's perspective. You're an investor, but you're also involved with infrastructure, and you wear, well, you brought your hat, so I know one hat you wear, but you wear other hats, and one of them is on the UK's infrastructure oversight, or whatever it's called, board. Yeah. Now, all of these solutions require infrastructure shifts or investment. How do you see that playing out?
Yes, true. Thanks, Joel. I sit on the British government's infrastructure board. It's called Infrastructure UK, and it sits inside the Treasury but has a little bit of a distance. And the idea is that group helps to build and then implement infrastructure plans for the whole country. And clearly, transportation is central to that, and so is the requirement to deliver greenhouse gas reductions over time, because the UK government has a legal obligation, statutory obligation to work within a budget of carbon emissions. So this sector is critical. Fossil fuels are at the center of the problem. Finding alternatives to those, in this case oil, is part of the long-term strategy of building a more resilient, resource-efficient, and cleaner economy. And you need to invest heavily in the infrastructure to deliver those ends. And I'm particularly interested in the fact that the car industry is already producing attractive alternatives, because in the end, the transformation that we must make cannot be a form of punishment. Right? There has to be something alluring in the transformation. In the end, it's only beauty that will save the world. So if the car is attractive, that's very important. If it functions better than what came before, that's terrific. But still, it needs an infrastructure to be in place for it to be really available for large numbers of people, and we have a scale problem. It doesn't matter if a few individuals find this attractive. It has to be a big shift. Now that infrastructure has to be designed in a way, and I find Yossi's argument very compelling, that make many options available. You want that infrastructure to allow for diversity. And you might want to think very laterally about what that looks like. It might not be anything like what is there today. You may be able to find the place where you refuel your fuel cell in a different spot to where you customarily get your oil. It doesn't have to be in the same place. Just as we're finding out with electric vehicles, you're not going to the same places to charge up your vehicle. You may find that as the variety of vehicles increases, so the offering to the consumer becomes more diverse, and there's a sort of celebration in that. That in various parts of the United States, well, over here we know this is our fuel that we use. We made this here. And that might be attractive, and more attractive than having a single brand that provides a single type of fuel to all customers. But when you look at this as a national government or a state government trying to build the infrastructure, you are going to have some serious negotiations with the incumbents. And I'm not at all clear what the current incumbents are going to do about this. But I am clear that just like in the power sector,
And when you say incumbents,
I mean the current providers of
providers
fuels.
of fuel.
Yeah.
Okay.
They'll clearly listen to the car companies. That will have to be a dance done together. But these ideas are disruptive, and so you have to imagine that there will be new entrants, and that they might come from an agricultural setting. They might come from commodity companies stepping into that space. They might come from retail brands. We already know that an awful lot of the fuels we currently buy are supplied by people with brands that nobody sees. And a lot of the blends, which are critical, the small amounts of alternative fuels that are in our traditional oil-based fuels come from people nobody's ever heard of. Right? So you can imagine many new entrants coming into this space, and we're going to have to reimagine how they are delivered to the customer, and they may not be in the forecourts we've got today. And they're quite likely, I think, in some respect, to go back to the beginning. You can imagine, you just picture yourself, I'm sure you all have a picture in your mind, it's part of the American culture, of the mom and pop store and the pump outside. Well, you've seen for some years now a lot of the refueling happening inside in the UK, we call them supermarkets, but big malls. I can imagine that connection being remade, that where you're going to go anyway to collect your groceries or take your children to school or go to some public building, you may be able to be recharging, refueling, or getting the energy required to move your vehicle.
So let's go back to Chris, and the interesting thing, by the way, from a business perspective, is that we're talking about disruption.
Yeah.
And aside from one or two players, for the first time, or one of the first times in business history, the disruptions have to come from incumbents who are already successful and who are very typically 50, 60, 70, even 100 years old. So that's a different type of disruption. We haven't seen that in an industry. But let me ask you, Chris, from your perspective with regard to infrastructure to support your new vehicles, what do you see as the requirements, and how do you see getting there?
Good question. Okay. Just a little bit of perspective in terms of how fast the automotive market can change. Remember, we launched Prius 15 years ago, and it's been the #1 selling car in California for many years. So within 15 years, we can go from small sales of fuel cell to it being the majority, which is what I was trying to convey about our overall goal. We'll go from thousands in the industry initially as we try to get the initial infrastructure launched. And in California, we're very fortunate that they're making investments at the pace of $20 million a year to launch hydrogen fueling stations. And when we get to 60 stations, hopefully by the end of 16, we'll have enough infrastructure to support 10,000 cars. And so we hope to build a good business model in California, to set a good service model that no one's ever experienced before, let people appreciate the benefits and the tremendous joy of driving this type of zero-emission car. The only thing it produces is water. That's its exhaust, hydrogen and oxygen together. And we need to send a message so that we can build that dream into states on the East Coast and the national government. Because currently, there's this chicken and egg phenomenon that it takes so much money for an independent station operator to make an investment in his island or a unique station. And he needs sufficient vehicles on the road for him to generate that revenue. So the state of California helps with about 70% of his CapEx, but there still is a little bit of an investment issue for him over the first initial years. So we talk to all the different hydrogen suppliers, people who are integrators, governments. We try to collaborate with all of these people. This phenomenon is going on in California, It's also going on in Germany, where they're trying to build 100 stations, in England, where they're trying to build 60 stations, and Japan, where they're trying to build 100 stations. So all of these companies are getting together, discussing terms, trying to provide some leadership, but collectively, it's about to happen. And then the question is, what form will it take and how can we expand it? Because if it is only a California phenomenon, the goal that we have, again, is a zero-emission vehicle. And we appreciate, we have 280 million cars in the United States. So there are solutions, plenty of solutions for all of our businesses to make cleaner transportation. But the goal we have is to try to get zero-emission vehicles popularized. And that's almost a movement in terms of building this infrastructure.
And of course, just as a point of information, it depends how you make the hydrogen. Of course, the vehicle can be zero emission, but if you make the hydrogen with coal, you still have an issue of emissions. They're just somewhere else in the.
Well, that's a good point. People ask, how do you get the hydrogen? So one of the most affordable ways today is to make it from natural gas. And actually, when you look at the tremendous efficiency of the vehicle, the path to the best use of natural gas is not to burn it in a car, not to make it into electricity and send it to an electric vehicle. It's actually to make it into hydrogen and put in an electric vehicle. And that's why countries like Japan and China and Korea and Germany, who depend on other resources, are very interested. 2.5 times more efficient than a gasoline vehicle. So the efficiency argument is tremendous.
So Yossi, you collect information on this, and if you are looking at this option as one of many that are out there for vehicles of the future, and you look at producing hydrogen from natural gas as one alternative, very good for the U.S. given the natural gas bounty the U.S. has. Do you see this as ultimately a win for consumers in terms of price?
I don't know, because the prices will be different. I don't know, and I don't expect to know. I don't think anybody can forecast anything in terms of where prices will go and technologies. I think if anybody, when we opened AT&T, nobody thought about cell phones, okay? So I'm not looking at the fuel cell vehicle of today, as he says, what, 11 generations already? Of the fuel cell. The fuel cell will move, okay? So will the electric cars, so will other engines. I'll just give you an example. MIT did a study that said that most cars today are tuned to run on low-octane fuel from gasoline. Now, ethanol and methanol are a very high-octane fuel. That's why race cars drivers use them all the time, because you can really get high compression. He said, if actually those fuels were ubiquitous, I could double mileage on almost all the cars, new cars built. With changes, we don't have to invent. They already exist in the racing industry. So we already know what we need to do. We don't need to invent anything. And those are technologies we haven't invented on availability. So once you open the market and things happen, there'll be a lot of changes. There's innovators. There's American innovators. People will figure out how to combine hydrogen with something else and make maybe a hydrogen and methanol fuel cell, and then you'll move in 10 years to make some small modification to do that. I don't know.
But if you're talking about a installed base of 250 million vehicles,
right,
an average price of, I don't know, $25,000, $30,000 for a new vehicle, maybe more, somewhere in that range, let's say. That's a very significant investment, and people are likely to look at that in a conservative way, aren't they?
I think maybe, if I may add, it takes $300 or less to convert the car. And you can use to convert the car to run an ethanol and methanol existing car. If it was legal, it's illegal to do, by the way. Okay, that's part of the problem. But if it would be legal, which is just regulations that we have in this country right now, then there's a very interesting question. We have natural gas, okay? So just give the money-making opportunity here. In 2011, I think, or 12, the increase in natural gas production in the U.S. was 1.7 trillion cubic feet. That's roughly $6-7 billion in today's prices. This can replace, if you convert it just as an example, I'm not recommending the fuel specifically, but if you converted it as a pathway of methanol, you could replace $28 billion of gasoline, just from the delta of 1 year, if the market was open. I think most people can figure out a way how to make money between 28 and 7. Okay? And I think what is interesting about it is this is a future investment, huge investment Toyota and other people took. It will probably be various forms of electric cars in the 2030s will probably be the majority of new cars sold, maybe or probably. The question is, how do we make money today, and how do we reduce the cost of fuel today? So one solution is the trucking industry, but for the regular car, it's CNG. But for the regular car, is converting them and running them on fuels that exist today, and investments that could be made very quickly today.
So Andrew, are you looking at some of these developments? You have a very successful business. You're expanding it across the country in terms of long-haul trucking. That's a very significant market. Are you looking at these developments and seeing, is this something for me as a...
Well, the way I look at it is so today in the United States, and I have experts here, so if I get too far off, correct me, okay, but there's about we use in the United States about 175 billion gallons of gasoline and diesel. And we have about darn close to 300 million vehicles, all right? So we've just looked at how can you, for our business and for natural gas, which by the way, I started this business with Boone Pickens 17 years ago in LA, and there were no economics associated with it. I mean, zero. It was all because we had, natural gas was much cleaner, certainly a lot cleaner in those days, 17 years ago than gasoline and diesel. But when you look at the heavy duty, if you sort of look at all the fleet trucks, give you a lot of data, a lot of fleet vehicles in the United States, there's about 8 million of them out of the 300 million. 3 million of the 8 million use 35 billion gallons out of that 175 billion gallons. So when you really get focused, you can make for the country, you could do a lot of good and relatively easily. You have a tougher chore because there's 118,000 gasoline stations in the way we do it, now. But there's really only 5,000 diesel depots-ish in the United States. So we've already built a few hundred of those. And you can displace with natural gas 35 billion gallons. Economically, today, natural gas, the reason you'll see today, and I'm not an expert on methanol, other than I've always struggled with the fact that we're taking our good natural gas and we're using twice as much of it to make methanol to put it into the gas tank than if you just burned it directly. Now, I'm sure there's smart guys out there working on that equation, but that's always been the drag on taking natural gas and using 2 times as much natural gas to make a vehicle run on than if you just burned it directly. And I'm sure someone will figure that out. But we can make a big impact in the country, I think, for the right reasons and create a hell of a lot of jobs. You're already seeing it. I mean, billions of dollars are being spent around the world. In 2000, we took our company, the only reason I know this, we took our company public in 2007, and there were 5 million natural gas vehicles in the world. And today there's about 18 million. And so it's happening everywhere. It's because we have economics on our side. Today, our fuel is $1.50 to $2 a gallon cheaper than gasoline or diesel.
But you can assume, I mean, this is a car right now, but we're also talking about a power plant, essentially, and a propulsion system.
Yeah.
So this is one of my other hats is I sit on GE's Eco-Imagination board, and they have this CNG in a box technology, which we're very pleased with. And there's no doubt that there's a link between gas used in this way and distributed power systems. And distributed power systems offer you many, many advantages. I mean, they're clearly a huge advantage if you're not on the grid now. But there's something about a highly distributed power system that is more robust, more secure, more resilient. We had that really alarming lunchtime briefing yesterday on cybersecurity. Well, let me tell you, a highly dispersed, diverse energy system with multiple nodes is much harder to attack from a cyber point of view. And so I see real attractions in having the fuels discussion that we're having, mostly related to transport, also being connected to distributed power. And that expands the nature of the marketplace enormously. It's also true that many of the innovations will come through the connection between the engineers that know about how fuels perform and the engineers who know about how electricity performs and how to combine the two and what ways to get maximum efficiencies between the two. The other thing that the car industry and the power sector needs to have intense debates with is how to improve the conversion, the efficiency of the conversion, but also the management of the power. So you're seeing interesting things in motor racing, for example, with in Formula One with the KERS technology. Well, that KERS technology started as a power technology about how to do storage, energy storage, and now it's been brought into the advanced motor industry with brilliant engineers thinking, how can I store power that microsecond longer to release it just when it needs to be released to get the maximum performance out of a vehicle. And in each of these occasions, what the engineers are doing is they're making things better. They're improving. And under intense competition, they're doing, if you watch a Formula One racing car team disassemble a car after a race, it's pretty inspiring. I mean, they take every piece away and they take weight out. The other great factor in all this is materials. So, alternative materials to steel make a massive difference to the weight and make the performance improve and make the fuels go further. That's the other dimension. And we're having enormous advances in materials, in material science. Watch what's happening with graphene, for example. That's a great invention at the University of Manchester. So this space is now a creative space. And in a way, I think it has been, unfortunately, neglected by a lot of investors. So I want to tell any investor in the room, energy conversion, primary to usable energy, is a huge investment space.
Yes, but
and these are all examples.
But James, so how do you make the right bet, though? I mean, if we're talking about a future of 5, 6, a dozen, who knows, different types of fuels, isn't that a risky set of investments?
Only if you don't think monopoly. I mean, if you accept a world of diversity, there's so much the demand is enormous and growing. I mean, so I sometimes wish I never heard of climate change, but I have to, unfortunately, think about it all the time. So you have this pressure the whole time to reduce emissions, constantly, forever. For our generation and for the generations to follow, we're just going to have to deal with it. That's real-world fact now. On the other hand, we have growth in demand of massive scale all around the world. People want to drive their cars. Cars are alluring. They're terrific. And so this is our equation. Now, that provides a massive marketplace, but it also ought to provide great opportunity for various solutions. Lots of range.
I want to expand maybe a little bit on that, because there's two markets in gas, and maybe but there are two markets in CNG cars, in CNG trucks. One is new cars. The second is conversion of existing trucks. Not everybody can afford to buy a new engine. What's not known so much in this market right now, if you want to convert today in most places in the United States to convert your truck to CNG, you're waiting 6 to 12 months for parts. This is a booming industry right now.
And then how long? How difficult is the conversion? How long does it take?
Well, nothing. You put the truck in, out, another day. But I mean, it's nothing.
The real problem, Joel, it's not a big deal because it's really the fuel system. But a lot of the reason it doesn't happen, you're exactly right, is they don't meet the EPA certifications. That's the rub, is that there's a lot of conversion companies, but they can't afford to do the certification to get it past the EPA, so therefore it doesn't happen.
So let me see if I understand that we have a better fuel in terms of the environment, and the obstruction is the EPA, which is supposed to protect the environment?
Yeah, but in their defense, and you don't hear me defending the EPA all that often, but I mean, they don't. You can make a lot of us can make a conversion that's dirtier than gasoline. If you're not careful. So that's.
So are there accepted conversions?
Oh yeah, absolutely.
Okay.
California's got rules.
Chris?
Yeah.
I just wanted to make one point. So I started by saying, yes, we can make hydrogen out of natural gas, but we've been working with startups in Boulder, which is really Green Valley in terms of solar to hydrogen. UCI, which is really a center. Southern California is really going to be the center of hydrogen fuel cell vehicles. They've done substantial work in making hydrogen out of these wastewater treatment plants and also the refuse. And that green hydrogen very easily can go into a car, and that's what we're demonstrating with UCI. But I think what's most interesting is what's happening in Germany right now. So we would like our green hydrogen. We would like to have green hydrogen pump or green hydrogen to be the best path. And Germany is probably the best example. Around the Frankfurt Auto Show, that weekend before, 60% of all their electricity in the nation was produced by solar and wind. And so that changes the whole economics of their power grid system. And it's fascinating to see they're coming to a conclusion that hydrogen storage is key to their future. All the wind power that they get at night that they can't utilize, they can store underground in caverns. And that hydrogen can be put into green up the natural gas system, could be put into a transportation system, and can be used industrial. And people aren't aware there are hydrogen pipelines that people tap into, but the intersection between the electric generation business and the transportation business just magnifies the opportunities. And we're starting to see hydrogen in the early stages enter other industries. The next generation Airbus airplane will use a hydrogen fuel cell instead of a lithium-ion battery. Forklift trucks are rapidly
I hope the
comparing
787 does too.
Forklift trucks are rapidly moving to fuel cells, and we'll also be introducing a fuel cell bus because we think, again, on larger vehicles.
And that's why I asked you that this
Mm-hmm.
fuel cell technology is not just a platform, it's not just for a car.
It's modular and it can be used in
Okay.
other devices. And if you read the National Academy of Sciences report, when we're working on our internal combustion engine and we're making it adaptable to other fuels, with the work we have to do to get to the 54.5 miles per gallon, the 70% improvement, and we have 2 generations of products to get to those goals, the cost of those gasoline engines is going to go up like this. At the same time, the cost of fuel cells is coming down. So they predicted that in this scenario, that between 2025 and 2030, the fuel cells could be cheaper than the internal combustion engines. So at that point, this, again, could be a game changer. A game changer in our industry, a game changer for zero-emission vehicles. Could also be a game changer in terms of use of hydrogen in energy grid. Storing energy as hydrogen lasts longer. You can store it longer than if you try to put it in a battery.
I thought, Chris, I just had a question, because when I looked at this, I thought that when you got into serious scale in hydrogen, the only way you could do it was with nuclear, which is, I mean, I hear with Germany's got super expensive energy there. I mean, so that's not the answer.
Well, they have all this. They have huge wind power.
I mean, I mean, so maybe I'm just totally outdated. I just thought that was kind of the rub, is that the Department of Energy, if you ask them, well, how are you going to get to serious hydrogen? It was that you're going to have to get it from nuclear.
No,
Not necessarily.
I mean,
Not anymore. Well, that was a couple years ago.
the great thing about Germany has spent a lot of money building a renewable energy base, not just for current power needs, but for future, and also because they have a technological offering to the world if the world decides to go cleaner. So that's a big investment, and it's costly, but it's done, and there is no supply chain in light. Right? The sun continues to shine. There's no supply chain in wind. It just hits the turbine. So they are going to have years and years and years of very, very low operating costs and very, very low technological risk in a technology that they have spent a lot of money installing. So, and they have very little intermittency problem too, because they've got so much of it. Right? Now, clearly, we could improve that dramatically if you had more and you had a better grid and all sorts of other things that go with it. But that example from a day, it probably was a sunny day, but it is instructive. But it's also, Chris's point is critical about the nighttime wind. There's a lot of energy wasted in every system. But even a renewable energy system that's functioning at its optimum, very few grid systems are designed for renewable energy. There's a lot of nighttime wind. If you can store that, that's a massive boon.
When we were talking about storing it as hydrogen.
Yeah, exactly.
Which would be, yeah.
Exactly.
But,
Yeah.
you know, people, there's all kinds of techniques, and I don't want to forecast any one of them. I just can give you a technique. Iceland is taking CO2 and converting it to methanol. Okay? Yes. Correct.
Yeah.
Okay, it's happening in Iceland right now. There's a factory working and selling the methanol to the chemical industry in Europe. Do I think this can scale? Probably not. If I can get maybe to slide 11, if I may. This just shows you that we tend to think about oil as the source for gasoline and diesel. No, that's, I believe, 10. So if you can see that there's all kinds of feedstocks that exist out there, and we have the technology. These are not new technology. These are technologies, some of them are 100 years old, okay? And all of them are cheaper than gasoline, or most of them. So we can take natural gas and create CNG and LNG from it, because CNG doesn't come out of the ground compressed, okay? You have to dry it, clean it. It's also a processing, okay, that creates CNG. The same, we can generate ethanol and methanol from it. Just so you know, Celanese is building an ethanol plant in Texas from natural gas. I think forecast price is $1.50 a gallon, okay? Efficient, not efficient, twice. $1.50 a gallon is cheaper than $2.80 a gallon of gasoline. You know, there's a market, and if the car can take it, why not? Okay, that's and it's today. Okay,
I'd just
it's
like
not the future.
I'd like to point out something in this panel that strikes me that this actually is a very historic occurrence here. I mean, we're sitting with the largest automobile maker in the world, Toyota, is about to launch a second disruptive invention into the marketplace, Prius being the first. This is a very historic opportunity. There are questions about infrastructure, support, success that any entrepreneur has to face, but we're now no longer talking about and hearing the same arguments that for those of us who are at the beginning of some of these discussions, where you heard the automobile companies, the oil companies saying it's impossible. We're in this forever. We've got all this oil to use. So we have crossed that very, very large divide, and we're now trying to select or see what the market selects in terms of the winners. But we have crossed an enormous divide. Let me ask you one question, though. When you launched the Prius, which obviously was a huge game changer in terms of not just the technology, because there was technology like that around in different forms, but conceptually, mentally, people started thinking differently about transportation. Did you at Toyota expect it to be embraced to 6 million vehicles in a year and so forth, to these huge numbers?
So I would say that the success of Prius probably went beyond our original anticipation, but I think you also have to look at the context in which it was created. The context in which it was created was a resource-poor island, looking at China and looking at all the other countries in the world and wondering where they're going to get their resources for, planning a vehicle for the 21st century, and seeing the tremendous benefits that electrification comes from electrification, and having a consistent policy to develop and support, and also in the United States to support that technology. So in my career, I've worked on methanol cars, and these are all ethanol. We're very capable of burning ethanol in our vehicles up to E85, but there's no infrastructure for that. CNG, I did a CNG hybrid concept car. And his boss was the only one who liked that, and maybe the governor of Colorado. So we have had a lot of these experiments, and the ideal engine that would do what he would like would be a variable compression ratio engine that would be able to understand how much alcohol is being consumed, and would have a very good catalytic converter that in a normal gasoline engine, when you go to higher compression ratios, you produce a tremendous amount of NOx. Yeah. So theoretically, a multi-fuel engine is conceivably possible, and no one has done it yet. And primarily, I think we're at the stage now where I think that discussion could have been a national policy 10 years ago. Mm-hmm. Now the national policy seems to be, and I'm not saying there still could be a role for that. Our focus is how to get the carbon out completely.
Well, it's, yes.
Could we just circle back around to the...
And then I want to, by the way, I want to open it up to questions and comments in the last
At various stages, we've all kind of mentioned public policy and regulation and some things that don't seem to be quite in tune with the hopes and expectations that you hear on the panel. And it's true, there is confusion. We've managed quite well in Europe with quite demanding obligations to reduce emissions and to communicate to the consumer that that's going on. So most consumers in Europe, when they buy a vehicle, they know all about CO2 per mile or kilometre. They know all the numbers. They're all provided in the data. And the market's adjusted. That's extended a little bit into access to city areas, with the congestion charge in London being a classic example. But now, increasingly, cities like Paris experiencing serious urban air pollution, excluding vehicles or requiring people to have to have alternate days of access. And you sense that in a heavily populated part of the world, there will be more and more restrictions of that kind because of air pollution, which people experience in the way they don't really experience climate change. It's too abstract and remote, but they experience breathing dirty air or seeing smog. So that's part of what we have to build into these solutions, and they go to fuels, mostly to fuels. So finding out how to find the right balance between regulating the standards for the fuels themselves, the standards for the performance of the vehicles, the access to urban areas, the way in which there's an irrational difference between, for example, how alternative fuels are taxed and regulated in one country to another. Right? It's bizarrely different. I mean, irrationally different. We don't even have properly free floating alternative fuels prices, even in places like Brazil, where the oil market and the alternative oil market do not operate as free markets or anything like it. So there's still a lot of work to be done to get public policy to be in tune with the potential that you're seeing on this panel.
So let's open this to some questions. There's a microphone. We want, if you could identify yourself. Does someone have the microphone in back there? Because we're recording this, so the first question over here. Okay.
Hi, my name's Paul Tullis. I write feature articles for the New York Times Magazine. I wanted to ask Chris if you could address quickly the safety concerns that Elon Musk expressed on 60 Minutes regarding millions of cars driving around with hydrogen potentially running into each other. And I wanted to ask, is methanol a drop-in in today's infrastructure, or does it have the same sort of chicken and egg catch-22 problems as some of these other solutions, fuels?
And then next over here.
So regarding your question on hydrogen safety, that's a very good question. And there's a lot of experience now, obviously, in operating with gases, CNG, propane taxis. Gases in their transportation system have been entering the market without any interruption. The hydrogen has unique characteristics, which we feel in many cases even makes it a safer vehicle. One of those characteristics is the tremendous buoyancy of hydrogen. It wants to escape at 47 miles per hour if there is any type of leak. In the case of gasoline, it pools underneath you and it burns with tremendous violence. And even in the case of an electric vehicle, when you have a fire, there is a tremendous amount of energy that can be involved. In the case of a fuel cell, 1% of the hydrogen is outside the tank at any one time. So the key element is the safety of the tank and the design of that pressure relief valve. And these tanks are designed to the highest standards and aerospace standards, and all
they're
the testing that
woven
goes
tanks,
on.
aren't
Well,
they?
they're woven carbon fiber, and there's polymer.
What's the PSI?
We use 75 megapascals is what the hydrogen.
So what's, I mean, we do ours at 3,600 pounds. What are you doing hydrogen at? Our station's 10,000 pounds for hydrogen today. Is that what it is?
Well, 76 megapascals is what the
76
standard is.
megapascal. Okay.
Let's see,
Sounds like a
megapascals
restaurant.
But to continue.
Well, and that's not a
the-
concern then.
But let me finish on the safety front. So the other point is that with hydrogen efficiency, there's so much less fuel being carried on in the vehicle itself. You know, for a gasoline vehicle, you have 2.5 times more. And we can even get into what caused the Hindenburg, right, which is a separate issue, the aluminum paint, the iron oxide dust, the lightning that caused that, the diesel fuel that created a lot of the fire, and then later the hydrogen tanks did, the magnesium, which was used for the skeleton, which is highly flammable. It would be the worst possible combination, and the hydrogen was over in 60 minutes and it was venting vertically. We've actually had doctors and focus groups come to us and say, I much prefer a hydrogen vehicle for the safety element. So these are conversations we need to have and try and understand.
So so the bottom line is that there's a lot of misunderstanding about.
Yeah, we're saying it'll be as safe or safer than the other vehicles.
Yossi?
I think just as a comment on safety. One of the reasons race cars love methanol because it's much safer explosion-wise. It burns at half the temperature as gasoline, so your likelihood is, when you have an accident to burn alive is somewhat lower. That's kind of a thing that it's important for race drivers.
Hydrogen has twice the ignition temperature, so it takes 900 degrees for it.
But as far as methanol, the question is, of course, where? Even in places where you have a station that doesn't fit, it's probably no more than $100,000 a station because it's largely replacing a few rubbers in the pump. We know exactly how much because in the 90s, we did a test of methanol in California. As part of that test, California fuel pump standards was changed to fit methanol. We had methanol in like 40 or 50 pumps, but all the station standards were changed. And actually, probably the majority, we haven't checked, but we know a lot of stations do, that have been sold in California, pumps that have been sold in California in the last 30 years are methanol compatible without even, although they haven't been certified, but they are because they were all based on that change that was done in the 90s here. There are countries in the world that do that. China has 3 provinces running on methanol, so all that is about the cost of converting the station. Let's say building a CNG station or a hydrogen station is $1 million at least. Okay, we're talking about $100,000 per station, 100,000 stations around the entire nation. We're talking about $10 billion nationwide.
Not much
Small.
money.
Also for Mr. Haas.
Can you identify yourself?
Zan Dubin Scott. I run a small PR agency. And for Mr. Hofstetter also, what will the cost of the fuel cell vehicles be to lease or purchase to the consumer? And doesn't it take 4 times the amount of energy to produce hydrogen than it does to run a battery electric vehicle where you have no middleman, can be run on solar, and has been the adoption rate for battery electric vehicles has been 200% over the past 3 years, each year. And they are even running them, of course, with vehicles, companies like trucks, rather, companies like Coke, FedEx, and Frito-Lay. A lot there for you.
Good luck on getting the price out of him.
Price and price. So traditionally, when we're ahead of delivery of the vehicles at this period of time, we don't release a price. But what I can say, we have said publicly that it'll be higher than the price of a Prius and below the price of a Tesla. And some of our competitors are offering a fuel cell vehicle at around a $500 per month lease, and they include the fuel in that. So that could become a competitive benchmark for the rest of us as we launch the vehicle.
How many cars will you be delivering? Did you say 2016?
Next year, 2015. There'll be 3 manufacturers selling fuel cell cars in 2015, and by 2018, 2019, the luxury manufacturers, BMW will be utilizing our fuel cell. We have a joint venture. Most all manufacturers will be fielding a fuel cell by 2019 or 2020.
We'll have to go on to another questions here. Over here, right in front. Identify yourself, please.
Hello, Tanner Kraus with Come and Go Convenience Stores. My question for you is, do you see yourself, the whole chicken and egg mentality of this, the infrastructure needed to support the vehicles you're producing, do you see the manufacturers investing in renewable charging stations, and how does that look?
So that's an interesting question. In Germany, there's this consortium, and Daimler has some involvement in that consortium, along with the hydrogen suppliers, the government, the local provinces, and so they're taking a role. In Japan, one of our companies, Toyota Tusho, is working with, I think it's Air Liquide or Air Liquide. We work with Air Liquide on our Shell station, which is the largest hydrogen station in the U.S. right now. It's near Toyota and Honda. So you're seeing collaborations among manufacturers, and a lot of these discussions are on non-disclosure. So I can't say anything imminent about what we're doing. But I could also say, generally speaking, auto manufacturers, with the tremendous amount of R&D we put into this, remember Secretary of Energy Chu said that this was a very difficult thing to do. And so we made sure we had conversations with him and ambassadors to try to show people the progress we've made, that there is a lot of investment in science. And so we see that as really the province of the fuel suppliers to try to help us, carry the investments in the infrastructure area.
One thing to think about is that this is an infrastructure investment. It could be attractive to an infrastructure investor. It's also possible that the retail sector could make investments. I mean, we've experienced in Europe IKEA becoming a very substantial developer of renewable energy, which it uses for its stores, but also now provides into the grid. There are telecoms companies and internet businesses, and there are people who are interested in the systems that supply basic needs, of which energy and transportation rank very highly. So I wouldn't assume that the answer is going to come out of an existing fuel business.
I would actually maybe say that they will, on the contrary. If you, the ability to use a come and go. So 40% of the fuel station in this country are independent provider. And independent is not mom and pop. It's actually grocery or stores. So it's a Walmart, Costco, Wawa, Kruger. There's 40, and so they sell cheaper fuel so people can come and buy at the store. And that's what the mall model that you were saying. So I think that's where the change will come.
Rajiv Nair.
My name is Rajiv Nair. I'm an entrepreneur in the solar energy field. My question is for James. You mentioned about the distributed power systems needed and with the cybersecurity threat for the grids. And also, if you look at the East Coast in the United States, when the storms hit, there was no grid. And that's a serious threat, which is many states and many countries are going to face in the future. So what are the challenges in establishing these kind of distributed power systems using alternative energy like solar?
Well, that's why I'm interested in the relationship between fuels, transportation, and power systems. And I just think the space is opening up now for multiple versions. But you still need to build both a regulatory and physical infrastructure that enables it. And in many parts of the world, that regulatory and physical infrastructure is designed for incumbent technologies that have been there for decades. And you need power. I mean, power in the sort of political, and you need power to shift those incumbents out the way. And one of the sources of power is consumer choice, wanting something better, or commercial consumer choice, wanting to save costs. That's very powerful. And sometimes it's political action. It's an intervention that says, that somebody, and this is, I sense what we're in many parts of the world trying to do, trying to picture what a distributed power system looks like, how it relates to a distributed transportation system, and then finding ways of moving and creating space for entrepreneurs to enter in. And there are no simple solutions, and they will vary culture to culture. This culture has an entrepreneurial base to it, and in my view, I'm very optimistic about how the United States will transform itself around both distributed power and alternative fuels.
And we will do it without a plan.
And we'll,
Have time for one more question.
Absolutely.
My name is Ahmed Hekel. I'm from Egypt. And I would like to get your views regarding whether you think that where you start, your starting point on every one of those technologies, at the end of the day, will lead to a convergence into one model for everybody, or whether because the infrastructure investments have been quite large, that we may reach different endpoints in the technology.
Good question. Who wants to, Yossi?
I'll take you back to 1980, where AT&T owned your phone. Okay, and there was no cell phone, and long distance was AT&T, etc. And they said, "Oh God, if we'll put more people, the whole infrastructure will collapse, and we'll not have any more money around, etc." And luckily, one judge said, "No, you broke AT&T up, and you have to allow access to the local loop by other companies." And look what happened. The next, probably 80% of the U.S. GDP growth in the last 35-something years was the result of that one judge decision of opening the market. So if we, in 20 years, we're going to have only one solution, I'll be very worried. It's going to be very expensive.
So that's all the time we have for the panel. I'd like to thank you, James, Yossi, Chris, and Andrew, and thank you all for coming and for your good questions.